Okay, and this takes place, that fixed temperature at which this change takes place, that temperature is known as boiling point or vaporization point. Okay, for example, water, that is a liquid, at 100 degrees centigrade it changes into steam, that is a gas, which at 100 degrees centigrade by absorbing heat. Okay, now when this reverse takes place, that is when the vapor is cooled, it changes into liquid. It changes into liquid at the same fixed temperature, and this process is known as condensation. And the point at which the temperature at the temperature at that the fixed temperature at which this change takes place, that is from the vapor to liquid, and the change of gas to liquid. So that temperature is known as condensation point. Okay, now for example, the steam, that is the gas or vapor, at 100 degrees centigrade it condenses to water, that is a liquid, at 100 degrees centigrade on cooling, by rejecting heat. Okay, releasing heat. Now this can be explained by kinetic theory. Okay, so what happens when the liquid is heated, its molecules, they absorb the heat energy, and while absorbing the heat energy, the molecules gain kinetic energy. The kinetic energy which was there in the liquid, that increases. Okay, now the average kinetic energy of the molecules continues to increase, so the temperature of that liquid rises. Okay, now in turn what happens, the increase the that in when the kinetic energy has risen, what happens, the molecular spaces, the intermolecular spaces, that increases, and which decreases the intermolecular force of attraction, and this goes on till the kinetic energy of the molecules become more than that of the intermolecular forces, when the intermolecular forces, the force of attraction, that reduces, that is overcome by the kinetic energy of the molecules, that is kinetic energy of the molecules increases more than the intermolecular forces. Till that time, this intermolecular spaces, that goes on increasing, intermolecular forces, that goes on decreasing. Okay, this way takes place till, and after that what happens, the this at this stage, when the kinetic energy is more than the intermolecular force of attraction, during this stage the energetic molecules, they rapidly leave the liquid and change into the gaseous state at a particular temperature. Okay, till then the temperature was rising. Now in this state, the heat energy absorbed by the substance does not change the kinetic energy or the temperature of the substance. At this stage, when the liquid, the liquid is changing into gas, at this stage, at this particular fixed point, the temperature does not rises, and the kinetic energy also does not change. Okay, so temperature remains constant. At that temperature, at that fixed point, the liquid changes into gas, that is the state of the liquid changes into the gaseous state. Okay, but it is utilized, the heat energy which was being used to raise the temperature till now. After at this stage, when it is changing its state, at that point it is utilized in working against the forces of attraction. That is, force of attraction is overcome by the kinetic energy of the molecules, and therefore that increases the molecules kinetic energy. So the separation, that intermolecular spaces increases, and intermolecular force of attraction get reduced, increasing their potential energy. And what happens, the change of state takes place. Okay, now another way of changing this change of state, that is evaporation. Evaporation is also a process in which the liquid changes into vapor. Though it's a slow process, I'll tell you the difference between evaporation and vaporization of boiling or boiling. Okay. So evaporation is a change which occurs at all temperatures, whereas boiling was occurring at 100 degrees centigrade. Or vaporization was occurring at only at 100 degrees centigrade. But evaporation takes place at all temperatures from the surface of the liquid. Okay. Now we get the explanation of this evaporation in the kinetic theory. Okay. So in a liquid, the molecules, we know that they are always in a random motion within its boundary. Okay, while they are in a random motion in the within the boundary, they are colliding with each other, and due to this collision, some molecules below the surface of the liquid, they acquire sufficient kinetic energy to overcome the force of attraction of the other molecules, and their intermolecular spaces increases. Okay, and when their intermolecular spaces increases, their intermolecular force of attraction comes down, and these molecules move to the surface of the liquid, absorb the heat from the surroundings. Okay, and what they do, they gain more kinetic energy and they leave the surface of the liquid as a gas into the air. Okay, so that is evaporation. Now, basic difference between evaporation and boiling is evaporation is a process by which a liquid changes into vapor at a temperature below the boiling point, whereas vaporization is a process by which liquid changes into vapor at a boiling point, at the fixed point, that is a boiling point. Okay, and but evaporation takes place below the boiling point. Now, evaporation takes place at all temperatures, whereas vaporization takes place only at that boiling point, that fixed temperature. Now, temperature may change during evaporation, whereas vaporization temperature during vaporization does not change. Evaporation is a slow and silent process. You will not even notice when it is evaporating. But in vaporization, that's a fast process and the violent process, and you can recognize that this vaporization is taking place. Liquid is changing into gas. Okay. Now, in evaporation, that takes place only at the surface of the liquid, whereas vaporization takes place over the entire surface of the liquid. Okay. Now, the rate of evaporation of a liquid depend mainly on the following 5 factors. One is temperature of a liquid. When we increase the temperature of a liquid, the rate of evaporation also increases. Okay. Now, area of the exposed surface. When we expose the area of the surface of the liquid, increase that, then the rate of evaporation also increases. This can be understood from the example that when if we the cup of tea, if we give you a cup of tea, okay, so that hot cup of tea, you want to rather we want to cool it down faster, so we pour it in the saucer, because the saucer has a more surface area than the cup. Okay, so it will cool faster. So that is the area of the exposed surface has changed from the cup to the saucer. The cup has a smaller exposed surface, whereas the saucer had a more larger exposed surface, and the rate of evaporation will be more. Okay, and the liquid will cool faster. Now, nature of the liquid: volatile liquids with low boiling point, that is like alcohol, spirit, etc., ether, they evaporate much faster than water. So volatile liquids are stored in tightly closed bottles. Okay, like if we open, simple example is that nail polish bottle. If we open the bottle, we can smell that fragrance of the nail polish. Okay, and it is evaporating. It will dry faster if you open it and keep it. Okay. So next is the flow of flow of air above the liquid. So this is also the factor on which the evaporation difference. If the air is blown above the liquid surface, if air is blowing on the liquid surface, it moves away the liquid molecules of the liquid, which evaporates more quickly. So to cool milk, we generally blow air over it, that is, it cools down. Okay, then again, the pressure of the moisture or humidity. If the air is dry, okay, the evaporation is faster, whereas if the air is humid, the evaporation is slower. For example, the wet clothes, you know that wet clothes, when the weather is dry, if we put it in the sun, that it will dry faster. But when it is humid climate, that same wet cloth will take a longer time to dry, especially in the rainy season when the climate is humid. Okay, so this is here I should stop here. I'll continue with the rest of the video in my next rest of my chapter in my next video. So please go through this. If you have any doubt, please do write in the comment box, and if you like the video, press the like button, share with your friends so that they can also be benefited from this. Okay, and in my next video I'll discuss the applications of evaporation, how it produces cooling and other applications of evaporation, and the rest of the chapter. So if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.